Alright guys, today this is going to be probably a little bit more of a longer video because I'm basically going to be introducing you to your first CrackMe, your first reverse engineering. I'm going to be explaining what a byte is, the difference between the bit rates. Thank you to the constructive criticism I got in the comments the other day. I can't recall the person who did it, but yeah, in this video I'm going to be trying as best as I can to explain stuff that you may not understand, and I will try not to throw around vocabulary that many of you might not know. But first and foremost, I'm going to be explaining what a byte is. So a byte is an actual thing. It's a measurement for a lot of, I guess, binaries. If you don't know what binaries are, it's literally just ones and zeros. So one binary would be one, right? It would just be like one or zero. It would just be one of those things. Actually, it might be better if I visualize it. So, for example, this would be one binary, and then if I can make it into or if I were to call a bunch of binaries a byte, it would be 1, 2, 3, 4, 5, 6, 7, 8. So this would be a byte because it is 8 binaries. So it's basically just a measurement of that. So if we do, to explain what so the difference between a 64-bit application and a 32-bit application, we would have to, you would have to understand that a 32-bit is literally just 2 to the 32nd power, and then a 64 application would be 2 to the 64 power, and that's how many bytes that that are, I guess, I don't know if I want to say available, but like able to read. So for example, the program can handle, I guess is a good way to put it if you don't understand, it can handle this many bytes. So this would equal 1 byte equals 1 byte, and this would be 2 to the 32. A 32-bit program would be 2 to the 32. This is how many bytes it can handle. So I kind of understand what that is. You should also understand that a 32-bit software, so application, exe file, whatever you want to call it, cannot run or can run on a 32-bit operating system or processor. So if you don't know what a processor is, it's literally just your CPU. It's basically the brain of your computer. It's a 32-bit processor. It can run on a 32-bit processor, but a 32-bit processor, so CPU, cannot run a 64-bit program because this number is obviously much, much bigger than this is. So I don't know if that should give you a pretty good idea of why that would make sense. But yeah, so once you understand that, you can understand that on why most of you should have a x86 or 86-bit operating system or 64-bit operating system. If you have a 32-bit operating system, I'd be very surprised, but I'm pretty sure everybody does have a 64-bit one that is watching this video, so you don't have to worry about that too much, but just understand that you can run this, and that's what it means. And you should also understand that we have a separate debugger that we're going to use for 32-bit applications. So this would be our x32 DBG. So the assembly might look a little bit different in 32-bit assembly, and I will be explaining what assembly is in a little bit, but for now we'll leave it there. Moving on, we are going to be taking a look into the CrackMe.1 website and how you're going to read stuff like that. So let's head over into CrackMe.1. This site is one of my favorites. I've been using it for a while. It's very, very useful if you're trying to learn how to do specific things relating to cracking. So for all you beginners here, you can literally just go through this website. You just go to latest CrackMes, scroll down here. What you need to understand though, if you're going to be cracking CrackMe with x64dbg, which is the program I gave you in the setup, you might know it as m46asp.exe. That's what you know it as. But we are going to be always going to need to be language C, so C++. The architecture or the bit rate, the bits can be x86, x64, x32. Doesn't matter, but just know that if you're doing this, you're going to need x64 DBG, and then if you're doing a 32, you're going to need x32, which I showed before. Now the difficulty should be 1 to 3 if you're just starting out, and the quality doesn't matter too much, and the platform should always be Windows. That is pretty much the most important thing I would say related to CrackMe, So yeah, I'm gonna teach you how to use the search feature a little bit real quick because it took me a little bit to figure it out when I didn't know. Make sure language is C++. I always do this. Arc is always this, and then the platform should always be Windows. And then the difficulty I would always set for when I was first starting, it would always be 1 to 3. The quality can be anything, and I just hit search, and you see everything. So, yeah, that's basically a little bit quick tutorial on how to use this. Very important site, very useful. I really like it, and if you have any questions, just DM me on Discord or comment down below, and I'll try to answer them. So, moving on to our actual tutorial, what I have here is I have difficulty 3, which I got off CrackMe.1. I have a fake strings, and I have a very, very basic, just like one-on-one bare minimum CrackMe. So, yeah, let's get started. The first thing you're going to want to do is you're going to want to open DetectItEasy. So let's open that right now, die.exe. You have it in the setup folder. Okay. Yeah, so we have, you'll be a little bit here. Make sure that it'll look like this when you first see it. Make sure you check this advanced right here, and you will see this. It's very different, and it gives you a lot more options, but we are not going to be using any of these today. However, I will be explaining them as we get further into the course. So, DetectItEasy, what is this? It basically just gives us basic file information without opening the file. So, for example, if I was like, oh, I don't know what this file has, and I don't want to run it on my PC to see, so let's just see what DetectItEasy has to say, right? Just drag the exe into here. Make this a habit of always drag a file into DetectItEasy before you open it, because you will get a lot of info here. So we could see that it's a 64-bit program, which means we are going to be using x64 DBG. See the architecture AMD 64. Don't worry about this. Don't worry about this. Don't worry about this. For now, just look at the mode for a quick little look, and you're gonna want to make sure that you understand what these are. If we go to here, I always use NAS file detector NFD because it gives us the most info. As you can see, it shows the language it's coded in, and it shows the linker, and yeah. So that's basically it. I mean, I would always, just as soon as I drag the file in, I always go NAS file detector and I look from here. So yeah, and one thing that's also very important is you just click the virus total, and you'll have a virus total set up where you can see if there's any malware, if it's a logger or something like that. Yeah, but I will teach you how to use virus total in a separate video. But for now, that's just the basics you should know about DetectItEasy. You don't really have to know anything else. So yeah, so we see that is a C++ file, which means we use our debugger. We see that it's a 64-bit, so we use x64 DBG. That's what I've gotten here. We can also look at a lot of this but we're not as advanced yet, so we're just gonna assume this. I know it's x64 and I know it's C++, so that means we debug it. So let's go ahead and open our m46 asp.exe. You got this in the setup files video. And as an administrator, always run it as an administrator. If you don't, it sometimes won't be able to load certain files. So yeah. So coming into this, make sure you have it full screened. It will look a little, I guess, intimidating. It might be a little scary looking at it first, but you will be comfortable with this by the end of our tutorial. So yeah, let's use our open right here, this little icon right here, what is this doing? It's basically just saying, what file do you want to debug? That's all it's saying. That's it. What file do you want to debug? And we're going to pick the file here, and we're going to go find it. So it'd be in our week 1 files, and then CrackMe's all one. This is the one we want to debug, so we're just going to double click it. Now, this is going to be very intimidating at first, but don't worry. What does this mean? Well, what do we do from here? You might have no idea, right? But we could see that the module is ntdll.dll. So it's basically a system module. And if you don't know what a system is, it's like Windows, kind of Windows module. A module is kind of like a little snippets of code, I guess you could say, is a good way to put it, that we aren't really trying to interact with. So the program, when somebody's coding something and they code a couple of lines, it has to eventually like that line. So for example, printf would be just like putting it on a console, right? Like just putting a so if I go to cmd, if I were to do printf, right, just pretend this is a console window. If I did printf, it would just show up right here, just like printf hello, it would show hello here, right, in code. To print something, it has to contact the Windows thing saying, hey, do this. So the process of actually printing it would go through a system module, but we're trying to just go through the code, not actual system module. So I guess that's a pretty good way to explain it, but don't worry about any of the system modules. You're not going to need to do any of that. So I just recommend pressing run once, and you see this looks very intimidating, of course, but this isn't how all. There's something called the entry point. This is where we start actually being inside of the code. So all of these lines right here are all code. This is code, this is code, this is code, this is code, this is code. And this is something we call the assembly language. The assembly language is kind of the in-between of binary, which binary we learned before. Binary is a bunch of ones and zeros. It's the in-between of binary and code. So it's mainly for our CPU. However, humans can read it basically pretty well to an extent, but humans can't read binary perfectly well to understand everything. We could do basic math and stuff, but it'd be very impossible because of our brains can't really handle it all. But code we can understand. So if you look here, if I open up MS Paint, we have code here. This code then goes to assembly. So we'll make this a square. This goes to assembly, and then this goes all the way to binary, which would be a triangle. So this would be binary, this would be assembly, this would be code. So right now what we're looking at is the assembly here. And obviously, if you are more advanced, you understand what hex is, but I'm just giving the basic idea of what we're looking at here. So this is what we're actually looking at right now, is the in-between. So, yeah. What we're going to want to do is just don't worry about this any of this for now. It'll be another lesson. Just click this little run right here. This basically just runs the program all the way to a point where it's paused, or a point where we're gonna like in the beginning of something new, kind of. So it'll just run the program until it stops, right? Until something happens. So we're running, and let's enter our license. We don't have a license, right? But we want to make sure like we get a correct license. So what's gonna happen if we enter our license? Let's see. Well, it just says try again and then closes very fast. Well, let's do that again. Press run twice. And we're going to be like, wow, so how would I change this to go to logged in successfully, right? How do I do that? Well, simple. Well, first thing you're going to want to do is you're going to want to right click anywhere in this window. So anywhere in this window, just right click. And then you're going to want to go down to search for all user modules. Why user modules? User modules meaning the modules, so like the parts of the program that we have access to, like that we are trying to, I guess, manipulate in a way. We are trying to like modify, I bet. So the reason why we wouldn't want to do system modules or all modules is because we only want the user mode, is what we'd call the program, the user mode of the program. We don't want anything related to Windows being in there, or some weird stuff. Although there will be some weird stuff in user modules because of how compilers work and stuff. But for now, let's just do this. String references, and as you can see, we see the skull. Whoops. Hold on. I'm actually going to redo this search because of that skull. You see the skull here. And if we look here, it's the same skull. So this would be loaded in the program from this. So a string, if you don't know what a string is is just literally just this. So I'll show you a notepad. This is a string. It is multiple letters in a row. So yeah, that's pretty much it. That's what a string is. So if this is a string because there's multiple characters or letters in a row, it's a string of text. So now that we know this, we can like, oh wow, this is a skull. If I double click here, you don't have to worry about any of this, by the way. You don't need this. We're only going to be looking at this part. If you just double click here, whoa, it looks like, what is the program doing? Like, if you had to guess what we're looking at right now, you don't know assembly at all, what would you guess that this program is doing right here? Well, you should have thought that the program is literally just drawing the skull. It's just making the skull. This is exactly what it was doing. It was making this little figure here. So, but we don't want that. We don't want to modify, the figure being made, because that doesn't matter to us. What we want to do is we want to get past the login. We want to make it so that we're always successfully logged in. So how exactly would we do that? Well, we need to look for a string that's related to our login. So you might notice we see hello dear user, I hope you enjoy the challenge by user, right? And then enter your license. So we're going to want to look for enter your license, or like successfully logged in is a good one, or like wrong password, or enter your license, or hello dear user. We want to look for something like that. And as you can see, we actually see all of these here. We see the UN, we see the enter your verification, enter your license, and then we see hello dear user. So since we're at our enter your license, we're just going to double click here. And this is actually where we are in the program right now. It is waiting for us to enter our license, and then it will continue after that. So if we scroll down a little bit here, we will see that UN, pause, try again. Now you might notice when I click try again, this little thing on the left lights up. Well, what is this? This is simply a jump, is what we would call it in assembly. JNE means jump if not equal. So in this case, what this jump would mean is jump if our password is not equal to the correct one. If our password is not correct to the correct password, then we are going to jump to try again because it's wrong. But if our password is correct, it'll say welcome, let's continue, enter your verification. And we have gotten that far so far. So where we are in the code right now is we are right here. We're in here because we have not, obviously we have not gotten the try again message yet, and we haven't even entered our license. So we are right here in the code, right? So if you don't know what a call is, it's basically saying, hey, go to this part of the program and then until we say go back. So it's basically like sending the little kid to the room. It's basically being like, yo, go to your room until you feel better, right? So it's saying go over here, and you don't know what any of this is. I just double clicked, by the way, to follow all over here, and then it would be return back to your living room, right? It'd be, okay, you can come back out now. That's what, it's basically a basic idea of what that call is doing. So I'm just hitting the minus key until I get back to where I was, if you don't know what I was doing. So we're going to do a little thing where we're like, okay, so we want to modify this program so that it always says, logged in, right? We always want to be logged in. So what we're doing is we're going to set something called a breakpoint. A breakpoint is basically something that our debugger is saying, once the program gets to this address, so an address being a line in the code, once it gets to this specific line, we want you to stop and wait for the next thing that we tell it to do. So what we're doing here is we're going to set a breakpoint with F2 key. It's your key F2, or you can do breakpoint toggle. But we're going to do F2 on this CMP. And by the way, CMP because CMP right here. So now that we know, we're telling our program to stop right before it's deciding whether or not we are going to get the try again message or the welcome, let's continue. That's basically, that's what we're looking at here. So enter just whatever you want. We don't have an actual license key, so enter. And as you can see here, we have a, that's our license key, and then it is a CMP. CMP means compare. Compare is basically, if it's comparing right now, is a value, what we like to call a value. So, or a string to another string. So you don't know that, but we can safely assume that because we see our license key right here, and then we see that this is going to try again. So we could safely go, okay, well, if this is comparing something, and then this is jumping based on whatever this is comparing, we could safely say, oh, it's comparing our incorrect our license key we inputted to the correct license key, and then if it's wrong, it'll jump to try again, and if it's right, we'll be logged in. So yeah, so what we're going to do here is we're just going to use our little step over, which basically goes one line at a time. It'll go like this, so that we can see it'll just go like this, right? And rather than just running all the way to our next breakpoint or running until we the program stops or something, right? This just goes one line at a time. Is a good way to put it. So, yeah, it's basic analysis. By the way, I don't know if I explained this before, but RIP is where we are in the program. So this little arrow right here, this little RIP is where we are in the program. This is what we are looking at. So since we are looking at the RIP, this is where we are in the program right now. As we are at this compare, it is about to compare our incorrect license key that we entered to the correct one to see if it's correct. So once we have hit here, we could use this little step over so we can go one line. It's compared it now, and now it's saying that was not correct. So that's why it's red right here. This red right here basically says we are going to jump. We are going to do whatever this line is saying. So it's saying jump if not equal to here. This little thing right here, it's basically right here. That's all it's jumping to, is right here. That's what that means. It is jumping to here, to this try again message, because our license key was incorrect. So we don't want it to do that. So we could just say, hey, we don't want you to jump. So we're going to type NOP. NOP means no operation. No operation meaning just don't even do the code. This code is just there because it's filling the size of what we left off. It's basically like replacing kind of a block of just stuff that does nothing with the code that was there before. So it's being replaced, you know. So that's what we're doing, is we're just filling it with an OP. Make sure it says keep size, fill with ops, or you'll have errors, obviously. And you're gonna hit OK. And now you can see that we have these NOP right here, no operation. And we're just going to use step over. And as you can see, nothing is happening as we go over these. And don't worry about any of this. Let's see. Oh, welcome, let's continue. As you can see here, welcome, let's continue. That means our license key was correct, even though it was wrong. Alright guys, this is my third time redoing this entire part because for some reason my audio really just wanted to just kill itself. And then after, in the middle of me recording it, the second time, I blue screened. So I don't know if you can tell, but I'm in a really good mood. So yay. Anyway, as we're here, we're going to use our step over function, or our step over all the way till we get to this compare. Well, this is comparing something, and as you can see, if you click on the jump, it shows that we are in fact jumping to this right here, right? Like, why are we getting the try again? We want the you win message. We don't want to skip the you win. We want the you win. We win. We want to win, right? We want to win. So it's actually, if we want to win, and it's jumping over the you win, well, what are we going to do? Well, it's pretty simple. We're just going to do the same thing as last time. You step over until we get to the jump, if not equal, and spacebar NOP. Enter, cancel, and use our step over a little bit more. And as you can see, we have gotten the you win. So that's basically our first CrackMe. We're going to be going through this fake strings where I'm going to be doing a little bit faster, and I'm going to be leaving it up to you to make the decisions, and then I'm going to have you pause the video, and then you're going to do it, and then I'm going to do it right after you unpause the video. So from here, what would be the first step you do? Pause the video now. The very first thing you should have done is right click here, search for all user modules, string references. Now, you will notice this string right here, and you're gonna be like, whoa, why is there a website? I thought this was just a hard coded, which means the key is inside the program, not through a web server. What does this mean? Why is there a website? Well, if you double click it, we can see that is a bunch of useless mumbo jumbo information that it's not actually doing anything, meaning that the developer put this in here. The developer put this in here to specifically trick us. So if the developer put this in here to trick us, how do I know this? Let's think about this. Well, we see all of this here. Let's go API URL. This would be our API URL. It is displaying our API URL, but it's not actually connecting to anything. So why would there be an API URL, a version, a hash with client key, token, private key? You don't even know what this stuff is. Why would it be there though if we're not actually connecting to a server? Well, it's simple. The developer put us there to check. How do we know? If we see all of this, the only thing different is the RSP right here being added and subtracted through different numbers. And if we double click these calls, actually, it's all doing the same exact thing. So we can safely assume that this is just a bunch of mumbo jumbo nothing. This is just, it's not doing anything, we don't need it. So, ignore this. I would like you right now to tell me, where should the breakpoint be put? Pause the video now. You should have paused it, and you should have put the breakpoint on the CMP right here. And then we're going to enter a key, press enter, and we're going to hit our breakpoint. And we see it is comparing our FGH key that we have entered. So you can see the end of it here with ODAM. The correct key would be ODAM. How do I know this? Because we can actually make that safe assumption because of how it's comparing right here to ODAM, and then after that it's jumping if it's correct or not, if it matches. So use our step over, and we don't want to take this jump. And you might take a look at this right here and be like, well, why is there comparing and why is it looping back up? Well, this is a little thing just actually comparing the key a little bit more. So you see how that disappeared, and then OD8M is disappearing character by character. And now it's disappeared completely. But because we had gotten rid of this jump right here, it instead of right now the response would be this key is not correct. We should be going to the not valid. However, we have made it impossible for it to go to not valid. It is not possible right now at all. So that's why it is giving us our success message, as you can see here. So that was a little quick one. Now I'm going to challenge you to do the difficulty 3 completely on your own from the folder that you downloaded off our mega link in the description. So go ahead and do that now, and I will be running through it very fast right after. You should have paused the video and you should have been done with it by now. We're going to open our difficulty 3 and enjoy me speedrunning this. And as you can see, we see the you did it, yay. Now, how did I know? Well, let's go back to explain that there is a test, this to this. It's basically testing, and then based on that test, the outcome, it will jump or not. So in this case, it was testing our key, and it was not correct, so it was going to jump, so I just got rid of the jump. And the reason I didn't opt this jump was because this was jumping to not a valid input, but in this case, we did enter a valid input, so our input would be this. We entered something that was valid, but not the valid key. It was just valid. So I didn't need to change something here, but I did need to change something here so that we would get this message. And yeah, that's basically it for today. Thank you all for watching. I hope you've learned a lot today, especially if it's your first time. If not, you can wait for the other videos to drop pretty soon. Yeah.